Hello guys, Matt is back with another video, and today we are on problem 8. And I think this is a nice problem. It's a good one for us to see how far we've come with our coding. For the new people, if you haven't already subscribed, please click on the subscription button below so you get notified whenever I release a new video. I've copied the problem definition here, but it's not as clear as the others, so I'll go to Project Euler so we can see it in full. Here is the problem. It's called the largest product in a series. The four adjacent digits in the thousand digit number that have the greatest product are 9 times 9 times 8 times 9, which is 5,832. So let's just find where this thing is. So if we look for 9989, this is what they're talking about. They're saying they found a four adjacent digits that give us the greatest sum in this whole case. What I think they did was they looked at all combinations of four digits. So treat this as one number, one long number, 1,000 digit number. And then what they do is they look at the four, get the sum, and then look at the next four and get the sum, and then look at the next four from here and then get, not the sum, sorry, get the product. And then they at the end they see which one what was the highest product. So we're going to try and replicate replicate this for the four digits, and then see if we can get the greatest product for our 13 adjacent digits, which is what they are looking for. So let's go back to the code. So what I did now, I created this data folder here, and in this data folder, this is the number that we got from Project Euler. If you look at this number over here, I have a replace and something over there. The reason I'm doing this is because when I'm using the literal string, which is the text over here, and I press enter, so all this, if I do this, this space will be included in my data. But what this guy does over here is it removes all spaces, so things like tabs, next lines, and things like that. So we remove all of that. So this will essentially be one long number. So it will be one, instead of the way you see it here, when we actually read the number, it will just be one long number in a straight line going there. It's not like a grid the way we see it here. So that's why I did this over here. So now here we'll import the file from here. So I'll import the data from data there, and then and that's the one we're importing. And in there we are importing our data. That's what we get. So we'll be using this data to try and solve the problem. So what are we going to do? What we're going to do is we're going to loop through the data, and we are going to be moving by blocks of 4 or blocks of 13. So since we need our block to change sizes, we'll have a function that takes in that size that we want to look at. So I'll create a function called greatest product. And it takes in a number, and that number is just the length of the number that we want to see. So if you want to see 4 adjacent numbers, we'll give it 4. If you want to see 13 adjacent numbers, we'll give it 13. So I'll just give this n, and this is of type number. What do you want to do? We want to loop through our data. So if we go for let I equals to 0, so we're initializing it to 0, and then while it's less than the length of our data over there, so data dot length, because we don't want to because we don't want to exceed the length of the data that we're actually looking at. We want to increment by 1. That's what our loop will look like. So what do we want to do? So we want to find the greatest product and then return it to us. So I'll initialize the greatest product outside of the loop, which I'll initialize to start off. I'll just initialize it to negative infinity. So this is so that we'll be changing this guy, keeping the highest product as we move from product to product. That's I'm initializing it to negative infinity so that we don't actually get a case where we have something that is going to be less than the number we're looking at. So we know this is the smallest number we can look at. So as we find a product, we'll change this guy and assign it to the new product that we get if it is greater than the product that we currently have. So now we want to find the product of the number. So I'm going to create a function outside of the loop here, which is, I'll call it get product. And what does this take? This should take a substring of our text, of the text that we have over here. So we'll find the text, which is going to be a string. And then what I want to do is I want to return the product of the number. So I'll return text. So I'm going to split the text and multiply the digits together. We've seen how we split our text by an empty string and we get an array, and we'll get an array of each number in the text, right? And then we want to reduce our array to a product. So we'll be calling this function for all the elements in an array. This guy over here is our callback function, and this guy here is our initial value. What our callback function takes, it takes in your previous value. So I'll call this memo, which is memory, for memory, which is the number we're keeping. So to start off, this memo value will give us 1. And since we'll be multiplying all the values in our array, that's why I'm making this 1, because we'll be multiplying. So when we multiply a 1 by any number, we get that number. So that's why I'm doing this. And this will be our current value, as you can see there. So I'll just call it CURR. That's our current value. And then what do we want to do? We want to multiply memo by that new number that we get. But this thing over here is a string. So we want to turn that string into a number. So I'll go plus. So I showed you this before, that the plus, let me close this guy on the side. So I'll go plus, and then this will be a number, and then we'll multiply it together. So this is what our product function looks like. So we'll use our product here. So I'll go const, not console, const product would be get product. And then what do we want our text to be? So we're looking at numbers of the length n. So from our data, we want the substring of this length. Data dot substring, we want the substring. And then what is the length of our, where do we want to start? So you see here, it says from what position do we want to start? We want to start from position I. And then we want the length of n because of the length that we gave to this function over here. So this will be our new product. If you see, we get a number from there. So this is a number because this product function here takes in a text and gives us back a number. So this product here is a number. Now if the product that we have here, so actually if this product that we get now is greater than our highest product, what do we want to do? We want to take our highest product and assign it this new product that we get. So in this way, we make sure that we always have the highest product that we've looked at in this case. So our return, and then at the end of our loop, we'll actually have our highest product. So I'll return our highest product over there. Now let's see what we get for Let's see what we get the greatest product being for 4. So we saw that for 4. Let me just save this file as well. So we saw that for 4 here, we want the product to be 5,832. So let's see what we get. I'll just run, and the name of our function is greatest product. And then we get 5,832, which is what we got there. So we can actually just change 4 to 13, save that, and see what we get for 13. Let's see. So let's put in our answer. 657875. 6575. Let's see if that's our real answer. And that is correct. So see you guys in the next video.